Number 9, solve the equation 2x to the fourth power minus 5x third power minus 27 equals 0. X is complex numbers. Find all solutions. Since this is a calculator based, we are looking for all solutions. We will put the function into graphing calculator to get the rational roots. Go to y equals, we put in 2x to the fourth power minus 5x to the third power minus 27. Then graph. We need to figure out these two roots. This one is a positive 3. Let's use a calculator to verify. 0, that's 2. 1, 2. So let's put the 2 as the left bound. Right bound, this is a 4, so press 4. Enter. Enter. 0, x equals 3. For this one, second trace, go to 2. We use negative 2 as the left bound. Right bound is negative 1. Then enter, enter. They give you negative 1.5. After we figured out these two roots, we will use synthetic division to figure out the rest of the roots. From graphing, we get x1 equals 3, x2 equals negative 3 over 2. Synthetic division. Root in the corner, no missing power. 2, negative 5, 0, 0, negative 27, because we have 0x squared plus 0x. Drop down, 2, multiply 6, 1, 3, 3, 9, 9, 27. We get 0. Keep doing this synthetic division. This time we will do negative 3 over 2. For negative 3 over 2, we know the factor is 2x plus 3. So we take 2 out. We can get x plus 3 over 2. After we did synthetic division by using negative 3 over 2 as the root, don't forget divided by this 2. 2 divided by 2, then multiply by negative 3, negative 3. Adding negative 2. Negative 2 divided by 2, multiply by negative 3 is positive 3. 6. 6 divided by 2, multiply by negative 3, negative 9. 0. Don't forget divided by 2. So we have 1, negative 1, 3. For the degree, x to the fourth power, x to the third power, x squared, x. Then here's a plus. So we can write down 2x to the fourth power minus 5x third power minus 27 equals x minus 3, 2x plus 3, then times x squared minus x plus 3. We will set up this equals 0. We have to use a quadratic formula. For x squared minus x plus 3 equals 0. A equals 1, B equals negative 1, C equals 3. So x equals, we know the formula, x equals negative b plus or minus square root b squared minus 4ac over 2a. Negative b will be 1 plus or minus. Negative 1 squared is 1 minus 4 times 1 times 3 over 2 times 1. So we have this is 2. 1 plus or minus square root. 1 minus 12 will be negative 11. So we have final answer. 1 plus or minus square root of negative sign will be I. Square root 11. This will be x3 and 4. So all the solution to this equation will be x equals 3, negative 3 over 2. 1 plus or minus square root of 11i over 2. Let's go to number 11. The polynomial x to the fourth power plus p x to the third power plus q x squared plus rx plus 6 is exactly divisible by each of x minus 1, x minus 2, and x minus 3. Exactly divisible, which means x minus 1, x minus 2, and x minus 3 are the factors of this polynomial. In other words, 1, 2, and 3 are the roots of these polynomials. So we have f of 1 equals 0, f of 2 equals 0, f of 3 equals 0. We will use these three equations to figure out the value of p, q, and r. F of 1 equals 0, which means 1 to the fourth power plus p times 1 to the third power plus q, 1 squared plus r times 1 plus 6 equals 0. Simplify 1 plus p plus q plus r plus 6 equals 0. Since there are three variables, we will use a matrix to figure out the solutions. For the matrix, you have to change into standard form, which means ax plus by plus cz equals d form. So we have p plus q plus r equals negative 7. For f of 2 equals 0, 2 to the fourth power plus p times 2 to the third power plus q, 2 squared plus r times 2 plus 6 equals 0. Simplify 16 plus 8p plus 4q plus 2r plus 6 equals 0. 8p plus 4q plus 2r equals negative 22. This is the second equation. This is the first equation. For f of 3 equals 0, we will get 3 to the fourth power plus p times 3 to the third power plus q, 3 squared plus r times 3 plus 6 equals 0. This is 81 plus 27p plus 9q plus 3r plus 6 equals 0. Changing into standard form, 27p plus 9q plus 3r equals negative 87. This will be the third equation. We will put this three equations together. That is p plus q plus r equals negative 7. 8p plus 4q plus 2r equals negative 22. 27p plus 9q plus 3r equals negative 87. I will show you how to use the matrix to solve this 3 by 3 system of equations. First of all, we need to change into matrix. PQR, the coefficient is 1, 1, 1, then negative 7. Remember, when you want to use a matrix to solve system of equation, you have to change every single equation into standard form, which is ax plus by plus cz equals d form. For second equation, we have 8, 4, 2, negative 22. For third equation, we have 27, 9, 3, negative 87. Then we will put this matrix into calculator. This is a 3 by 4 matrix, 3 rows and 4 columns. When you decided to use matrix to solve this system of equation, you don't have to simplify the equations. Like a second equation, we know the common factor is 2, but since we want to use graphing calculator to figure out the solution, you don't have to simplify this equation. We know the matrix is second x to the negative first power. Second x to the negative first power. Go to edit. This is rows by columns. 3 by 4. Then we have 1, 1, 1, negative 7, 8, 4, 2, negative 22, 27, 9, 3, negative 87. Then remember, after you put in matrix, you have to quit second mode. Then go back again. Go to Math, upper arrow, RREF, enter. Then go back to this matrix again. Enter, enter. We know the variable we put PQR. So this is a P, this is Q, this is R. We know the variable is PQR. So this is P, Q, R. We get P equals negative 7, Q equals 17, R equals negative 17. So the solution to A will be P equals negative 7, Q equals 17, R equals negative 17. Now let's go to B. Find the fourth root. We know this polynomial function, x to the fourth power minus 7x to the third power plus 17x squared minus 17x plus 6. We want to figure out the fourth root. We already figured out x1 equals 1, x2 equals 2, x3 equals 3. We can use a sum and a product of roots of polynomial functions to figure out this x4. We do know x1 times x2 times x3 times x4 4 equals -1 to the 4th power times c over a. For this polynomial function, we know a equals 1, c equals 6, equals 6. x1 is 1 times 2 times 3, then times x4 equals 6, x4 equals 1. Or you can use some of the roots of polynomial functions. x1 plus x2 plus x3 plus x4 equals -b over a. b equals -7. That equals 7. So 1 plus 2 plus 3 plus x4 equals 7. We know x4 equals 1. Or you can put this function into, or you can graph the polynomial function in the graphing calculator to figure out the fourth roots.